KCET 2025 aspirants, welcome to KCET Master Stroke series, and today we are going to do one shot of the chapter Aldehydes, Ketones and Carboxylic acid. Now let me tell you that this is a very high weightage topic, and this is also little lengthy because you have so many reactions. You have all the king functional groups, aldehydes, ketones and carboxylic acid. So many reactions are there in this chapter, but do not worry, I will cover all of them. You can watch this one video and can complete the entire chapter, and you can go and write your exam. Okay, so do not worry students. So I want all of you to sit with a notebook and a pen and write down all the important things. Whichever flow chart I am making, please pause the video, make the flow chart and then move forward. Okay, so yes, now coming to the content of this video, what all things we are having. So I have divided basically it in 4 parts. Okay, so you will be studying about, in the first part we will be studying about the basic thing, that is nomenclature, classification and preparations of aldehydes and ketones, means those method by which we can prepare both aldehydes and ketones. Okay, now next part comes your preparation of physical properties. We'll be discussing about the physical properties, chemical reactions, the lengthiest part, as well as the, okay, this is not there. Okay, next we'll go to carboxylic acid, nomenclature, we'll discuss about its structures, method of preparation, chemical and physical properties. Okay, so basically whenever we have a functional group, we have 3 things to study about that: methods of preparation, physical properties and chemical reactions. Okay, so let's start first of all about weightage. So weightage, you can see 5 marks have also been asked from this chapter, so you can definitely expect 4 to 5 marks from this chapter in 2025 examination as well. So coming to the first part, as I told you, we'll discuss about nomenclature, structure and the preparations of aldehydes and ketones. Okay, so let us jump into, so in this we have again 3 things, that is preparations of aldehydes and ketones together, means those methods by which we can prepare aldehydes and ketones, the same method. Then there are some specific methods for aldehydes and some specific methods for ketones. Okay, we will understand that as well. Okay, now moving forward to the nomenclature part. So the common name ends with aldehyde. So for example, if 2 carbons are there, acetaldehyde. If benzene is there, benzaldehyde. Okay, now if you have this carbon which is called alpha, then beta bromo 1 2 3 4, right, butyl aldehyde, you can name it. Similarly, you have here acetone, here it is acetophenone, here it is propio 1 2 3, right, propiophenone, and this is benzophenone. Okay, these are some common names. Next, coming to this one, the IUPAC name. So for aldehyde, one second, yes, so for aldehyde the suffix used is al. Okay, means the name ends with al, and for ketone it ends with one. Okay, ketone ends with one and aldehydes end with al. Okay, now coming to the first one, if there is 1 carbon, we call it formaldehyde or methanol, 2 carbon acetaldehyde or ethanol. Now if you have this structure, that is like this, 1 2 3 and then 1 2 3 4. Okay, here we have CHO. So this is your isobutyl. Okay, this group is isobutyl aldehyde. Okay, isobutyl aldehyde, and you will call it as 2-methyl propanol. Next, here something is very important when it comes to cyclic chain. Okay, when you have cyclic chain, what you have to do, see, this is their first carbon, second carbon, third carbon, right? So this is alpha, beta, gamma. So gamma methyl cyclohexane carbaldehyde. Okay, and when you name it in IUPAC, it is 3-methyl cyclohexane carbaldehyde. This carbaldehyde name is very important because we often forget that and we write cyclohexanol. Many students do this mistake. So please remember, put this as a note point. Whenever there is CHO group attached to a ring, you have to use the word carbaldehyde. Okay, so what is the key word you have to remember today? Carbaldehyde. Okay, fine. Moving forward, here you have one second. Okay. Next, what we have, next structure, please see quickly. We have this one where we have been given with CH3, okay, CHOCH3 and CHO, okay. So this is your you can say like alpha carbon. So on the alpha carbon you have methoxy group, so alpha methoxy propione aldehyde, okay, alpha methoxy propione aldehyde. And if you go for IUPAC name, what will be there? 2-methoxy propanol, okay. Now if you have this one here, this is very important, from here questions have been asked repeatedly, that is Valer aldehyde. What is Valer aldehyde? Your 1, 2, 3, 4, 5 pentanol is called as Valer aldehyde, please remember, okay. And then if you have this one prop 2-en1-al, okay, these two compounds are important, it is called as acrolein, okay. The name, please remember, Valer aldehyde and acrolein, okay. Questions have been asked from here. Now if you see two CHO groups adjacent to each other, it is called this is phthalate and here it is benzene 1,2-dicarbaldehyde, okay, benzene 1,2-dicarbaldehyde. Here it is meta-bromobenzaldehyde or 3-bromobenzaldehyde, okay. Next, coming to ketones. Ketones you have to write, see the ketones group naming is similar somehow to alcohol ether group. You have an R group here, you have an R group here, you have to name this R group, you have to name this group, then you have to tell ketone, okay, common name. So suppose CH3 is there and ethyl is there, right? Methyl propyl ketone, methyl propyl ketone. Now here we have diisopropyl ketone. Next we have here alpha methoxy cyclohexanone, okay. Next here you have macetyl oxide. So please remember this structure also, macetyl oxide, okay. Fine. Next, moving towards the structure, okay, structure of carbonyl compound. So C group, okay, the C which contains the oxygen, it is having a double bond, so that carbon is sp2 hybridized. And remember always, whenever there is sp2 hybridization, the molecule is planar, okay. Planar means it is present in one plane, the carbon, the oxygen and the two other valencies of the carbon are in the same plane, okay. So that is what you can see here, this is the plane, okay. Now there is a double pi bond between carbon and oxygen and that takes place above the plane, okay. So now what happens, this carbon, because of this oxygen, is highly electrophilic in nature and it is always attacked by nucleophile, okay. Whenever nucleophile comes, attacks on this position of carbon. Clear? That was all about structure. Now we will go preparations of aldehydes and ketones. So as I told you, in preparation we are going to study in 3 different parts. One, where the methods are like preparation of both aldehydes and ketones. Second, where we have to study only about the preparation of aldehydes. And third, where we have to study only the preparation of ketones, okay. Let's start quickly here. So this flowchart, I want all of you to draw it so that while revising you can easily revise from these things, okay. So first of all, when we have preparation of both aldehydes and ketones, the first thing that you can do is from alcohols, right. In the previous chapter, alcohols, phenols and ethers, we have studied that primary alcohols on oxidation will give you aldehyde, secondary alcohols on oxidation will give you ketones. That method is clear. By dehydration of alcohols, again dehydration means copper at 573 Kelvin. Primary will give you aldehyde, secondary will give you ketone, okay. Next, from hydrocarbons, here it is important, one is your ozonolysis and another one is the hydration of alkynes, okay. This ozonolysis is very important, I will discuss it in detail. That is there. Next, coming to preparation of only aldehydes. So when you prepare only aldehydes, the first one is your from acyl chlorides, RCOCl. Then you can prepare from nitriles and esters, okay, from nitriles and esters. Then you have from hydrocarbons, that is your oxidation of methyl and benzene, chlorination of side chain and Gattermann-Koch reaction, okay. Now coming to preparation of ketone, you have same thing from acyl chlorides, then you have from nitriles and you have from substituted benzenes, okay. We will be discussing all of this. Let's move forward. First, coming to preparations of only aldehydes and ketones, okay. So here, as I told you, there will be first one from oxidation of alcohols, dehydration of alcohols and from hydrocarbons. So this flow chart is very important. So if you remember from oxidation of alcohols, I already told you that primary alcohols on PCC or CrO3 will give you aldehyde. Secondary alcohols with PCC or CrO3 will give you ketones. Okay, this we have studied already in the last class. Now coming to the dehydration one. So this is your first method. So we had three methods, like the second one is your dehydration, that is the reagent used here is copper at 573 Kelvin. So if you take primary alcohol and react with copper at 573 Kelvin, you will get aldehydes. If you take secondary alcohol and react with copper and 573 Kelvin, you will get you will get ketones. Clear? That is the second method. Now third method is from hydrocarbons. Okay. So here, when I have from hydrocarbons, there are two things. One is from ozonolysis, okay, and another one is using alkynes. So ozonolysis, what happens? See, this is very simple concept. Any compound you take, okay, you do ozonolysis, okay, ozone with Z and H2O. Simply what it will do, it will break this bond. Okay, suppose this bond is there, this bond will break. How will you do after that? After this bond is broken, you have to add one oxygen on this side, one oxygen on this side. Okay, this is done. So anything which is present, so if here H is present, you will get aldehyde. If here R is present, you will get ketone. Okay, that is the basic thing. Next one is what? Using alkyne group. Okay, so when you have alkynes group, see, suppose you have let me write, okay, propine is there. Okay, so when you add here water, okay, in presence of Hg2 plus, okay, so what will happen? It will follow Markovnikov's rule and we will get, this will be like this, okay, CH3 and H. Now after that what happens, there is something called as tautomerization. So when this tautomerization take place, this bond, this CO bond will form. This structure is called as enol. Why it is called enol? See, we have en comes from this double bond, OH comes from alcohol. So now what happens when this lone pair of electrons are moved here and there is a tautomerization taking place, we get CH3. Okay, so this is the way how we can obtain aldehydes or ketones from alkynes. Okay, so if you have formaldehyde, ethyne, okay, then you will get one aldehyde. Okay, so that is the methods of preparation using methods of preparation from which we can prepare both aldehydes and ketones. Now we will move to the methods where we have only aldehydes. Okay, so we have a lot of methods here. Yes, so first one is your from acyl chlorides. Okay, from acyl chlorides, how can we prepare acyl chlorides? Means using our C double bond O Cl. I want this all of you to draw this flow chart. Okay, when you are revising, you should see this, then only you can revise better. Okay, so that is done from preparation of only aldehydes. The first thing that I can take is from acyl chlorides. The next one what I have, nitriles and esters. In nitriles and esters, we have one thing is Stephan reduction and another is dibyl H. We will talk about them. Then next one is from hydrocarbons. Okay, so from hydrocarbons you can do by oxidation of methyl benzene. Then you have chlorination of side chain and Gattermann-Koch reaction. Okay, let us see quickly these reactions. So first one is yes, so the first one is from acyl chlorides. Okay, so I'll write here first one, you can see acyl chlorides RCOCl. Okay, so if you take, so this is your from, please draw this flow chart. Okay, okay, so if you take H2 palladium and barium sulfate, then what happens? This chlorine gets replaced with hydrogen. Okay, this chlorine gets replaced with hydrogen and we get aldehyde, and this reaction is called as Rosenmond reaction. Okay, this is the first one from acyl chlorides. Now second one is what? The second one that you have seen is, it was your from nitriles and esters, right? So if you see the second one, that is from nitriles. Okay, so from nitriles we can first treat it with SnCl2 and HCl. Here what will happen, HH will be added, then if you do hydrolysis you will get aldehyde. Okay, this is one reaction present, and this reaction is called as Stephan reaction. Okay, and another one is directly by using dibyl H. From nitriles you can convert it to aldehydes by using dibyl H. What is dibyl H? Diisobutyl aluminium hydride. Okay, diisobutyl aluminium hydride. This is done. Okay, now after that from esters also it is there, right, from nitriles and esters. So using nitriles you have two methods, one is Stephan reduction and another one is dibyl H. The another compound is your esters. So from esters also by using dibyl H you can convert these esters to aldehydes, or yes, esters to aldehydes by using dibyl H and water. Okay, so that is your second method, that is from nitriles and esters. Now third one is what? The third one is from your hydrocarbons. Okay, so under hydrocarbons you have first one is your benzene, that is your what is that, methyl, oxidation of methyl benzene. Okay, so if you have any methyl benzene, okay, you treat it with CrO2, Cl2 and CS2, you get an intermediate and you hydrolyze it. Okay, so this is called as your Itard reaction, right? Yes, this is one way of oxidation of methyl benzene. You can also oxidize methyl benzene by using only chromic oxide and acetic anhydride. This one will give you also benzaldehyde. Okay, these are the two methods from where we can get by oxidation of methyl benzene. The second one was what? Side chlorination. Okay, so if you do side chlorination, right, so here what will, if you treat it with chlorine and HNu, this H gets replaced with chlorine, then you treat it with water and it will get hydrolyzed and you will get aldehyde. Now what happens? The fourth one, that is your from Gattermann-Koch reaction, take benzene, reacts with COHCl, AlCl3 or CuCl, you will get RCH. I know it is little confusing, but yes, we will do it once again. Let's revise it. Okay, so the first one is from RCOCl. Okay, so if I take RCOCl and I treat it with H2 and I want all of you to write with me. Okay, once again you should write with me. All of you should write with me this time. Okay, so what will happen? This Cl will be replaced with H. This is first method of preparation of aldehydes from acid chlorides, right? And what is the name of this one? This name reaction is Rosenmond reaction. Yes, all of you have written? All of you have written? Okay, now we will move to the second category, that is from nitriles and esters. Okay, from nitriles I have two methods. See, if I am taking nitriles, I can treat it with SnCl2 HCl. Okay, then I will get RCH double bond NH, and if I do hydrolysis I will get RCH double bond O. Okay, just the structure is little not on the way. Okay, okay, now this is what, this is one way, and I can also treat it with dibyl H. Okay, if you also treat it with dibyl H, here also you will get RCHO. Okay, now this one is called as what? Stephan reduction. Okay, now if you have ester group, okay, ester group, if you treat it with dibyl H, you will get again RCHO. This is done. Fine, 1 and 2 is over. Now coming to third method. Okay, I'll clear this one. Okay, now see, third method is what? From hydrocarbons, right? Third method is from hydrocarbons. So under that, see, from hydrocarbons, so after studying, no, you should write like this one time so that you can remember all the things. From hydrocarbons, okay, so the first method under hydrocarbons is oxidation of methyl benzene. Okay, so I have here two methods for oxidation of methyl benzene. Okay, so you take benzene, take CrO3, okay, and CS2. Okay, one second, just a minute, it is CrO2Cl2. Oh sorry, that is your retard reaction, right? Okay, so methods of preparation using from hydrocarbons. Okay, I have this third category, this is the third method. Under that I have first one is oxidation of toluene. Okay, while making notes you can write it as short as possible. Okay, oxidation of toluene. Here you have benzene, you treat it with CrO2Cl2 in presence of CS2, you will get one intermediate and the final product is CHO. Okay, next another, this is your Itard reaction. Next what I have, if I take, sorry, you have to take toluene. Next you can take toluene, treat it with CrO3 and CH3COO whole 2O, that is your acetic anhydride. If you treat this one, you will also get benzaldehyde. Okay, this is the first part gone. Now what is the second thing here? Okay, oxidation of toluene. Next one is chlorination. So in chlorination what happens, you take this CH3, okay, you treat it with chlorine H nu and you get here CHCl2 and then you do hydrolysis and then you will get CHO, benzaldehyde. Okay, now coming to next one, that is your Gattermann reaction. Okay, in Gattermann reaction what will happen? Gattermann-Koch reaction, you take benzene, react it with COHCl, AlCl3, okay, you will get CHO. So how many reactions we have studied? 1, 2, 3, 4. 4 reactions only on the third category. Okay, so yes, that is there. Okay, so now I can just once again discuss this one. This all reactions I have discussed. Now we will go to reactions or preparations of only ketones. Okay, so here also we have same thing from acyl chloride, first one, from nitriles, there also we had from nitriles, and then from substituted benzenes. Now coming to this one, from acyl chlorides, there we used to use hydrogen palladium barium sulfate, right? Here you have to use R2CD. This Cl group is replaced with R group. Okay, this Cl group is replaced with R group. That's all happening here. Then coming to nitriles, so if you have nitriles, you have to treat it with Grignard reagent. Then what will happen? This is plus, this is minus, this is minus, this is plus. So plus will take minus and this one has happened. Then you do hydrolysis, you will get ketone group. And next one is your nothing but Friedel-Crafts acylation. So if you take RCOCl, AlCl3, you will get RCOR. Okay, that is the preparation methods of ketones. Now moving towards the next thing, we'll solve some questions here so that we can understand what whatever we have studied, are we able to solve the questions or not. So the oxidation of toluene to benzaldehyde by chromyl chloride, CrO2Cl2. It is a name reaction, just now we studied, that is your Itard reaction. Okay, next question, yes, CH3CN is given in presence of sodium amalgam. Then we have this one. So okay, fine. So this reaction we have studied in the last class, right? CH3CN in presence of sodium amalgam will give you CH3OH. Now if CH3 CH3 CH2 NH2, so CH3 CH2 NH2 is produced here, right? This is your A. Now what happens? If you react with nitrous acid, what I will get? I will get CH3 CH2OH. Now if you treat it with copper at 573 Kelvin, primary alcohol, you will get ethanol, that is option number B here. Okay, next, which of the following reagents will convert CH3COCl to CH3COH? So you see chlorine is getting converted to hydrogen. Which one? This one, hydrogen palladium barium sulfate, that is your Rosenman reaction. Okay, next we have this Hg2 plus and H plus. So you have pH, C triple bond C, H3. This is interesting question. See, H plus and OH minus you have to attach, but OH minus will be attached to the more stable carbocation. So here what happens, because of this phenyl group there will be resonance. So this one will be more stable, and here we will get OH, and here I will get H, and then CH3. Okay, next what will happen, pH, C double bond O, C H2 CH3. Okay, so what is the option here? 1-phenyl, or you can see, okay, the name is, so that is your option number A, right? Because right after the pH carbon we have double bond O, and that is only present in option number A. Next, okay, we will discuss in this, now we will discuss about the physical properties and the chemical reactions. Okay, this is very important. Talking about in physical properties, boiling point and solubility. In chemical properties we have some very important reactions: nucleophilic addition reaction, reduction, oxidation, reactions due to alpha hydrogen, and some Cannizzaro reaction or other reactions. Okay, so let us start with first boiling point. So you know, alcohols have very strong hydrogen bonding, right? So alcohols form alcohols have very strong hydrogen bonding, so they have high boiling point. After that we have aldehydes and ketones, because they are polar in nature, they form hydrogen bonding. Next, ethers, they are also, like, the boiling point of ethers will be least if you compare alcohols, aldehydes and ketones and ethers. Now coming to solubility, so the lower members are very easily soluble in water, okay, because of hydrogen bonding, but the solubility will decrease with the increase in the R group. When the size of the R group will be more, the solubility will decrease. All aldehydes and ketones are fairly soluble in organic solvents. Okay, this is all about solubility. Now the most important part, that is chemical reactions. Okay, yes, you can see so many reactions are there here. Okay, so first type of reaction is nucleophilic addition reaction. Second reaction is reduction reaction, right? Third is oxidation. Fourth one is reactions due to alpha hydrogen. Fifth one is your other reactions. Under other reactions we have Cannizzaro reaction and electrophilic substitution reaction. Now coming to nucleophilic addition reaction, so as I have already told you, okay, before understanding this one, see, as I have already told you that this group, this is carbonyl group, right? This carbon is electrophilic in nature. Okay, if it is electrophilic in nature, then definitely nucleophile will attack on this one. Okay, so this is why we have, so there can be different nucleophiles, and we have studied it like haloalkanes. You remember Rx was there, and we have given a list of nucleophile. If this nucleophile will come, this product will form. If this nucleophile will come, this product will form. Similarly, in this case also there are 6 types of nucleophile in which we are going to study them in detail. Okay, so let us see them. Yes, so first is what? Addition of HCN, addition of NaHSO3, Grignard reagent, alcohols, and addition of ammonia and its derivatives. So not 6, 5 types of nucleophilic addition reaction. Addition of HCN, addition of NaHSO3, addition of alcohol, Grignard reagent, and ammonia and its derivative. So the basic mechanism is same thing. The only thing you have to understand here is what is the nucleophile produced. Now if you see HCN, okay, in HCN, H plus is there and Cn minus is there. So what is the nucleophile produced here? Cn minus, right? Similarly, in Na plus is there and HSO3 minus is there. So what is the nucleophile here? HSO3 minus. In Grignard reagent, you have RMgX, okay, so you have R minus and Mgx plus, so R minus is the nucleophile. Alcohol, you have ROH, oxygen has the lone pair, so this oxygen is the nucleophile. Now ammonia and its derivative is little different case, we will talk about that in detail. Okay, now let's see this 4 first. Yes, so coming to the first one, that is addition of HCN. Okay, so if you have HCN, CN is the nucleophile, so this nucleophile will attack on the carbon. So carbon will have this CN now, right? Now you see how many bonds this carbon is having, 1, 2, 3, 4, 5. That is not possible. Carbon can have only 4 bonds. So what will happen, this bond will break and oxygen will take this hydrogen. Okay, so you get this type of compound. This compound is called as cyanohydrine. Okay, so this is your first reaction, that is reaction with HCl. Next, coming to reaction with NaHSO3, what will happen here? Okay, yes, so now if you have this one, okay, so Na plus and HSO3 minus. So here what will happen, first here negative will come, here positive will come. So to the positive what will take, HSO3 minus will be taken. Okay, one second, plus minus, right? So HSO3 minus will bind with this carbon, okay, and O will take this Na. After that there is some what we'll say proton transfer and all takes place. This H plus goes there and this one comes here and we get this product. Okay, this is the second one, that is addition of NaHSO3. The third one is your addition of Grignard reagent. This is also very simple, minus plus we know, O minus will take Mg plus, Cr will take, then you do hydrolysis, OMg plus X will get converted to OH. So just let me explain you like this here. Okay, you are taking RMgX. So what is here minus, here it is plus, here minus, here plus. So if I just do crisscross, so C will take R, okay, and O will take Mgx. Now you have to do hydrolysis after that. Once you do hydrolysis, this OMgx will get converted to OH. Okay, so that is what you will get. Okay, yes, clear? So one second, yes, so this one is your first one, that is your cyanohydrine. Okay, next here is addition of NaHSO3. Next here is third one, addition of Grignard reagent. Now fourth one is addition of alcohol. Okay, this is also something which is important. Now if I show you addition of alcohol, so you can see this is carbon group, right, and I am adding one alcohol group. So what is happening here, this is the lone pair, this will attack here, this bond will shift here. So what happens, we get CC, then here you have O R dash, okay, and you have OH, okay, and you have O minus here, this one abstracts this one. So finally we get OR and OH, okay, finally we get OR and OH. Yes, okay. Now this part is called as hemiacetal. Okay, now if you again treat it with ROH, okay, so what will happen, I told you that day also that oxygen lone pairs are very active. Whenever they find hydrogen, they try to take it. Okay, so this will take this H plus and you will get OR dash, okay, and you have got O plus H2. Okay, now again what will happen, you have this RO minus now, this is a nucleophile, it attacks on this one, this O plus H2 leaves. So you get OR dash and OR dash. So this compound is called as acetal. Okay, so when you add excess of alcohol, you get acetal. With one equivalent of alcohol, you get hemiacetal. Okay, so that is under addition of, this is the fourth one, addition of alcohols. Now coming to fifth one, that is addition of ammonia and its derivatives. So simple, what happens, very easy one, you have to remember like this. See, this is ammonia, okay, I can write NH3 like this. So this group is removed, okay, and you get something like this. Now this group can be anything, okay, so actually this is represented as Z. Yes, this is represented as Z. So if Z is H, then it is ammonia. Whatever group comes, you don't have to think, you just have to find the 2 hydrogens of ammonia, remove it with this oxygen and then connect it with double bond. So based on this Z, there can be so many products you can see here like this. If Z is H, then it is ammonia. If Z is R, then you will get amine. If it is OH, then we call it hyd. So you can see this is the Z group, right? So this Z group can be anything, okay. So Okay, next you can find if it is NH2, we call it hydrazine. The product formed is called as hydrazone. This is phenylhydrazine. This is phenylhydrazone. Then you have 2,4-dinitrophenylhydrazine, 2,4-dinitrophenylhydrazone. Then you have NHCO, NH2 if this is attached. Okay, then you will get some semicarbazide and semicarbazone. Okay, fine. Now coming to the next one. So we are done with the nucleophilic addition reactions. Okay, now the second type of reaction is your reduction reactions. Under that we have two categories: reductions to alcohols and reductions to hydrocarbons. Reductions to alcohols is very simple, and reductions to hydrocarbons we have two reactions: Wolff-Kissner and Clemmensen reduction. Okay, so what is there here? So if you want to reduce it to alcohols, you have two reagents, LiLH4 and NaBH4. Okay, if you want to reduce it to hydrocarbons, means you want to replace this oxygen with two hydrogen, then you can use zinc mercurian amalgam. This is your Clemmensen reduction. Okay, and you can also use NH2, NH2, KOH and then ethylene glycol. This whole reaction is called as Wolff-Kissner reduction. Okay, that's clear. Fine. Now coming to next one, oxidation. Okay, so under oxidation also we have three types of oxidation: Tollens test, Felling's test and oxidation of methyl ketones. Now what is there in Tollens test? See, Tollens test is a mild oxidizing agent. Reagent used, so this one is your Tollens test. Okay, so what does this one do? This Tollens test converts this aldehydes to a salt and a silver mirror is formed. So if you are like want to identify whether there is aldehyde in that compound or not, then what you will do, you will take the compound, add some Tollens reagent. If you get a silver lining on the test tube, then you can assure that the compound has aldehyde group. Okay, so these all tests are only shown by the aldehyde groups. Now similarly you have Felling's solution or Felling's test. Okay, so you take copper salt in alkaline medium for, so this is your Tollens test, this one is your Felling's test. Okay, fine. Now what happens when you take this one, you get this Cu2O. Okay, this is the color of this Cu2O should be known, that is your red precipitate. Now one more thing, all the aldehydes will show this reaction, but except benzaldehyde. Okay, benzaldehyde does not, or any aromatic aldehyde does not show Felling's reaction. Now what is the reason for this? I will tell you after some time. Okay, this is there. Next is your, you can do like strong oxidation to give you primary acids group. Okay, so aldehydes can be oxidized to give you acids. Sorry. Okay, this is done. Now coming to this one, that is your haloform reaction. In haloform reaction, you should remember that we need this group. This CH3CO group should be present. If that is there, then we will get a product where this bond will break. This one will get converted to CHX3 and our C double bond O minus and Na plus product is formed. Okay, so this one is called as haloform. Okay, and this one is called as salt. Okay, so now generally we take X as iodine, so we get a yellow precipitate for iodoform. Okay, so this is only possible if you have this particular group CH3CO. Okay, if this group is not present, then you won't get this reaction. Clear? So now we are done with nucleophilic addition. 5 types we have seen: addition of HCN, addition of NaHSO3, addition of alcohols, addition of Grignard reagent and addition of ammonia and its derivatives. Next we saw reduction reaction, reductions to alcohols and reductions to hydrocarbons. Alcohols you can use lithium aluminum hydride and or sodium boron hydride, and reductions to hydrocarbons we have Wolff-Kissner and Clemmensen reduction. Now third reaction we are talking about is oxidation reaction, right? So in oxidation reaction what we can do, we can oxidize it to like Tollens reagent or using Tollens reagent, Felling's reagent. Okay, that will be giving you salts of carboxylic acid. And there is one more oxidation, that is your haloform oxidation reaction. 3 reactions are done. Next reaction is what? Reactions involving alpha hydrogen group, right? Yes, reaction due to alpha hydrogen. So here what is the name of the reaction that we are going to study is aldol condensation. Now before understanding this one, you should understand what is this alpha hydrogen. So if you have any aldehyde group, okay, so the carbon next to the aldehyde group, aldehyde or ketone, okay, anything aldehyde or ketone. So the carbon next to the aldehyde group, okay, should contain what? One hydrogen. Okay, this is alpha carbon, this is alpha carbon. So this carbon should have the hydrogen, and that hydrogen should be called as alpha hydrogen. If this alpha hydrogen is there, then this reaction will take place. Okay, so what is the first condition? You should have alpha hydrogen. Next, what is the reagent used here? Dilute NaOH. Okay, now let us first understand the mechanism little bit, then I'll be telling you a trick how to find the product. Okay, so if you have OH minus, okay, you will taking dilute OH, so OH minus will be there, so it will abstract this alpha hydrogen. Okay, so it will take one of the hydrogen from here. So what I will get? CH2 minus, this is formed here. Okay, now after this what happens? See, you take one more compound here, the same compound. Okay, now this negative one will attack on this carbon. Okay, this negative one will attack on this carbon, and this oxygen will move here, this bond will move here. So I can attach here like this. See, I have this one CH3 COH COH. Okay, so O minus, then in the medium there is hydrogen, it will take from here. Now what is attached to this one? CH2 and CHO. Okay, now what happens? You can see this one, this is alpha and this is beta, right? So we get a beta hydroxy compound during aldol reaction. Now if you give heat to here, okay, if you provide some heat, this carbon OH and this H will be removed, and you will get like CH3 CH double bond CH and CHO. So this is what? Alpha beta. Okay, so you will get alpha beta unsaturated compounds. That is the mechanism of aldol condensation, but you don't have to do these much mechanism in the exam. I'll tell you very simple trick. Okay, you have to follow just 2 steps to do this one. Okay, let us see now, just a minute. Okay, now see the trick here. Okay, so whichever alcohol, so now see, you can react between 2 aldehydes, 1 aldehyde, 1 ketone, 2 ketone. If the 2 reactants are same, then we call it aldol condensation. If the 2 reactants are different, then we call it cross aldol reaction. Okay, so I'll take a very simple example and I'll explain how to use the trick. Okay, so we are going to react between CH3 COH, okay, ethanol plus I can take ketone. Okay, ethanol and 1 ketone. Okay, now what you have to do? See, now what is there? This is suppose A and this is suppose B. So now this A can react with B, A can react with itself, B can react with itself, B can react with A. So if you take 2 different aldehydes, there is, and both of them are having alpha hydrogen, then you will get 4 products. Okay, so what is the point here? If 2 different groups and both have alpha hydrogen, then how many products will get? 4 products you will get. Okay, so now let me tell you the trick. So you want to add, suppose you want to write A plus A. The product of A plus A means this one is reacting is this one only. So what you have to do is you have to write the compound one below another. Okay, this is done. After this, what you have to do? You just have to do one step, that is remove this oxygen. Okay, remove this one and connect, see, this carbon, this adjacent carbon to this carbon which was having this CO group. These 2 carbon you have to connect. How will you connect? By double bond. Okay, so just connect the adjacent carbons with double bond. Okay, that is your product. How will you write it? So I can write like this. If I write in the straight chain, see, CH3 is there, then I have CH. Okay, then this carbon is having double bond CH, then you will have, okay, this is the product of A plus A. What is the name of this product? 1, 2, 3 and 4. So I can write but 2 ENAL. Okay, A plus A. Now let us do simply similarly B plus B. Okay, so if I solve now, B plus B means what? Acetone plus acetone. So it is like this. Okay. Okay. Now what you have to do? Just remove this one, right? So let me take the eraser. Remove this one. Remove this one. 2 hydrogen. Hydrogen you can balance. Connect it with the double bond. Okay. So what I am getting this product? How will I write? See, this carbon is having 2 CH3 groups. Okay, this carbon is having 2 CH3 group, this side double bond, this is one carbon, one side hydrogen, then you have like this. This is done. Next I will want to react A plus B. Okay, A plus B was what? Ethanol and acetone. Okay, means A I am writing first, then B I am writing. So same thing, I will connect this one, I will remove these things. Okay, so remove this one and remove this one. So what product I will get? C. This is what? CH3 is attached, then C. Okay, you have one H here, double bond, next another CH, then CO and then CH3. Okay, now similarly you can also do for B plus A. Okay, that I am leaving for you. You have to do B plus A and you have to tell me the answer in the comment section. Okay, so that is all about oxidation reaction of Cannizzaro reaction, and that is your aldol condensation and cross aldol condensation. Now talking about something called as Cannizzaro reaction under other reactions. So Cannizzaro reactions is happening when you have no alpha hydrogen. Okay, that's the first thing, and second thing is it happens in presence of concentrated NaOH. Okay, so here what happens is a disproportionation reaction takes place. You know what is disproportionation reaction? What is disproportionation reaction? In which one of the compound gets oxidized and it gets reduced. Now you have aldehyde or ketones. When it gets oxidized, you will get acid. When it gets reduced, you will get aldehydes. Okay, alcohols. So one very very good example is you can take benzaldehyde. Okay, so now see, this is the alpha carbon here. Now this carbon is not having any hydrogen. Here 2 bonds, here 1 bond, here 1 bond. No alpha hydrogen. So if I use concentrated NaOH, so what will happen? Here there will be a formation of I can say one OH will form, not OH, CH2OH will form, See, this CHO group will be reduced or will be converted to alcohol, and we will have one more group that will convert this one to actually acid. Okay, but instead of acid, because of this NaOH is present, we get a salt of this one. Okay, so this is about the Cannizzaro reaction. Now under other reactions we also have the electrophilic substitution reactions. Okay, so under electrophilic substitution, you know, if you want to do, so first of all, this CHO group or CO group, these are what? Electron withdrawing groups. Okay, so what position they will do? Meta positions. Okay, so now meta positions you have like CHO. Okay, and if you want to do nitration, just do concentrated HNO3 and concentrated H2SO4. So where will the nitro group will be attached? It will attached at the meta position. Okay, now similarly if you want to do Friedel-Crafts reaction, okay, CH3Cl Al Cl3, then on the meta position CH3 group will come. If you want to do for example bromination, Br2 FeBr3. Bromine will be attached at meta position. Okay, so that is about the electrophilic substitution reaction. Now let us see some questions here. Okay, too much lecture. Now let us try to solve this question. You can see here dilute NaOH is given. Okay, dilute NaOH means aldol condensation. Two products have been given. Okay, and we have to just find out the first A you have to find out. Now see this one, HCHO is something which does not have any alpha hydrogen. If you see here, right, there is only one carbon, right? The next carbon should be alpha hydrogen. Here there is no alpha carbon, so that is why no alpha hydrogen. So what will happen is if I have A plus B, okay, this B is not having any alpha hydrogen. So one product I can get is A plus A, another product I can get is A plus B. We won't get B plus B or B plus A, means this cannot attack on this one. This one can attack on this one. Okay, so how will I do? See, if I just remove everything, so what will be the product here? So the first one, that is your CH3CHO can attack, right? So I will write HCOH and I have this one. So what you will do? Remove this one and add a double bond here. Okay, so what I will do? Remove this one, okay, and add double bond here. So you will get a product that is CH2 double bond CH COH. Okay, this is what A is formed. Now after that, what is there? HCN. So HCN is what? HCN is the nucleophilic addition. So what will happen? CN will come here, OH will come here. So CN will attack because I told you this carbon is electrophilic in nature. So here CN will come and here OH will come. Now what is there? Hydrolysis, if you do, CN gets converted to COOH. So we want this product. I think this is the option. Yes, option number A is the correct answer. Okay, here there is no double bond, here there is no COH, here also no double bond. Okay, fine. Next, let's move to the next question. Okay, so here, okay, ammonia derivative, right? So you can see here it is like this. You have this one. Okay, let me write like this. C double bond of CH3 and you have CH3, CH2 and NH2. Okay, so this H2 will be removed, this one will bond, right? So what will happen here? CH3, CH2, N double bond C you will get, right? So where I am getting that? Am I getting it here? This one double bond N CH2 CH3. Yes, option number D is the correct answer. No, sorry, not D, B is the correct answer. OH is not there, right? OH is not there. You will get B as the major compound. Next, order of reactivity. Okay, so listen here, whenever we talk about aldehydes and ketones, okay, always aldehydes are more reactive than ketones because of their less steric hindrance. Okay, so aldehydes are more reactive. So you can see here that this one, first one is aldehyde, so first one will be more reactive. So I can eliminate option number A and B. Okay, now after you see here there is more hindered, big phenyl groups are present, here there is CH3 groups are present. So after 1 there will be 2 and then 3, so correct answer will be D option. Okay, next we will go to carboxylic acid and we'll study about its nomenclature, structure and preparation. So now after completing aldehydes and ketones, we have discussed their physical properties, their chemical properties, their methods of preparation. Now we will jump into carboxylic acids. Okay, in carboxylic acids, what all things we are going to study? Basic thing, the same part 1, what we'll be studying about nomenclature, structure and preparation. Okay, part by part we'll go. We are not going to study like now we'll focus on these 3 points. So what all things are there in this? So in preparation you can see that so many methods are there, but one very interesting thing is also here that many of the methods you already know. Okay, so from alcohols and aldehydes, oxidation we know. From alkyl benzenes, oxidation we know. From nitriles and amides, this is something new which we will see. from Grignard reagent. We know how this Grignard reagent works. From acyl halides and anhydrides. This is also, I think, something new we have to see. From esters, this is also we know if you hydrolyze it, we will get. So 1, 2, and I said 3, 4. Out of 6 methods, 4 methods we have already studied in some or the other way. So only 2 methods are new. So okay, we will now go to this one, that is your nomenclature. Okay, so if there is one carbon, we call formic acid and we call methanoic acid. If there are 2 carbons, it is acetic acid and it is ethanoic acid. If there are 3 carbons, it is propionic acid and propanoic acid. 4 carbons, butyric acid and butanoic acid. You see, in butane, no, always this R comes, butyl alcohol or butyl aldehyde. Okay, so that's what you should be keeping in mind. Now from here, something is very important. If you have CH3, CH, COH, then it is called isobutyric acid or it is 2-methyl propanoic acid. Now if you have COH, COH, okay, so this is your oxalic acid. So this is very important, you should remember here, OMSGA, okay, OMSGA, okay, OMSGA. What does it tell you? If there is 2 COH group COH, that is called oxalic acid or ethane dioic acid. If there is one CH2 group in between, okay, then it is called malonic acid. If there is 2 CH2 group in between, then it is called succinic acid. If there is 3 COH, 3 CH2 group, then it is called glutaric acid, and if there is 4, then it is called adipic acid. Okay. Now here what happens when you have 3 C groups, COH, COH and COH, then it is called tricarballylic acid. Okay, I am also not able to pronounce it, or you can simply write carballylic acid. Okay. So this OMSGA you should remember: oxalic acid, malic acid, malonic acid, succinic acid, glutaric acid and adipic acid. Here between 2 COH there is 0 carbon, 1 carbon, 2 carbon, 3 carbon and 4 carbon. Okay, this is important, you should remember. Now coming to the next one, benzoic acid. Okay, this is what? This is 1, 2. So 2-phenyl ethanoic acid or phenyl acetic acid, and this structure is also important, phthalic acid. Okay. Now coming to next one, we have some questions here. Let us solve this question. You have 1, 2, 3. So I can write 3-phenyl. This is propanoic acid. Okay. What will be the name of this compound? Number 1, 3-phenyl. Okay. Propanoic acid. Okay. Next we have here 1, 2. So what is the structure here? See, we have C double bond OH. Okay. Next we have CH. Okay. Next we have C, CH3 and CH3. Okay. First thing what we have to do, numbering. Let's do the numbering. 1, 2 and 3 on, and I can take it as 4. So on third carbon I have one methyl group. So I can write like this, 3-methyl. Okay, then but 2En, okay, but 2En oic acid. Next, third one is, this is cyclopentane ring. Okay, so for cyclopentane ring you have to use like 1, 2. So 2-methyl cyclopentane. Okay, cyclopentane carboxylic acid. Now coming to the next one, that is your fourth one. So let me go for the next one, fourth one. So this one is what? You have 2, 4 and 6 trinitrobenzoic acid. Okay, so it is 2,4,6 trinitrobenzoic acid. Clear? Fine. Now moving to the next one, question number, that is your structure. In carboxylic acids, the bond to the carbon lie in one plane because it is sp2 hybridized. Like, see, this all bonds lie in one plane. Okay, so here there is resonance. You can find the resonance here. Okay, resonance takes place. So the carboxylic carbon is less electrophilic than the carbonyl carbon. So if I have a aldehyde or a ketone group, okay, so what happens here, this delta plus and this is delta minus, but here you can also think delta minus and delta plus, but this carbon's electrophilicity is reduced due to the lone pair of electrons here. It donates the electron, right? So that is why the carboxylic carbon is less electrophilic than carbonyl carbon because of the resonance. Okay, that is clear. Very important thing. Next, coming to the methods of preparation, I told you there were 6 methods of preparation. First is from alcohols and aldehydes, from alkyl benzenes, from nitriles and amides, Grignard reagent, acyl halides and anhydrides, and esters. Okay, so let us see the first one. That is from alcohols and aldehydes. So the first one is this one, right? We have from alcohols or aldehydes, if you just use any strong agent like alkaline KMnO4 or CrO3 H2SO4 or even K2Cr2O7, these all will convert your alcohols, primary alcohols, but you should remember it is primary alcohols to carboxylic acid. The next one is what? Next one was what? One second. From alkyl benzenes, right? So this is from alkyl benzenes, the same thing. Whichever alkyl benzene you have, you just have to use KMnO4, KOH and H3O plus. This will convert one to this one. You can have 2 carbon, 3 carbon, 4 carbon, anything is possible, but final product will be benzoic acid. The next one was from your nitriles, okay, from nitriles and from amides. So first, when you treat nitriles with H plus or OH minus, you get amides, and amides, if you hydrolysis, you will get acids. Okay, so this is your from nitriles. If you start, you have to start from this one. From amides directly you can use. Okay, so this is from nitriles. Third one. Next, fourth one is what? Using Grignard reagent. Okay, fourth one is from Grignard reagent. So you have this RMgX and you treat it with CO2. So R minus will attack on this one, you know, this is minus, this is plus, carbonyl carbon, this one will attack here, this bond will shift, and this one will take you OMgX. After hydrolysis you will get this one. Okay, so this is your fourth one. Next, fifth one is what? Using acyl chlorides, and we had one more thing, anhydrides. Okay, so what happens if acyl chloride is there directly, if you treat with water, okay, you can get, so what will this is H plus and OH minus. So OH minus can attack here, Cl will go out, you will get this one. Or else there is another method, you can first treat water in basic medium, so that OH means you will get COO minus, and then you treat it with H3O plus. Both the methods are possible. Similarly with esters also, if you do hydrolysis, you will get. Okay, so this is your fifth one, that is from acyl chlorides. From acyl chlorides you have to use H2O, and this one is your sixth one, that is from esters. Okay, so with esters hydrolysis you can form acids. Clear? That is about the preparation. Now here's a question, what is the common name of simplest dicarboxylic acid? We know the simplest dicarboxylic acid is this one, that is your oxalic acid. So option number A here. Okay, next, identify the correct IUPAC name of the following compound. Now you know here this is 1, 2, 3 and 4. So ketone group, okay, when ketone group is used as a substituent, you know, this is the main functional group, this is the substituent functional group. So when ketone group is used as a functional group, the prefix that is used is oxo. Okay, so what we will get? 4-oxo, 4-oxo and 4. So we can eliminate option number B. 4-oxo cyclohexyl methanoic acid, 4-oxo cyclohexane 1-carboxylic acid, 4-oxo cyclohex. So ethanoic acid is not there. Okay, okay. So now what happens? This one here is 4-oxo cyclohexane 1-carboxylic acid. Okay, you know, if this is the functional group, you have to name cyclohexane 1-carboxylic acid. Okay, option number A. Next question, CH3 hold to NaCN and HCl, then you are doing HCl. So this is what, after you treat with this one, you will get CH3, CH3, then you will get Cn and OH. Okay, after you do hydrolysis, here you will get COOH. Okay, so what will be the name? You can name it like this. So it is like okay, in the above sequence you have to find both A and B. So A is your cyanohydrin, right? So CH3 whole 2 COHCN, CH3 whole 2 COHCN, CH3 whole 2 COHCN, CH3 whole 2 COHCN. A is correct for all the options. Now coming to B, this Cn will get converted to CH. So CH3 whole 2 COH, that is your correct answer, option number A. Okay. Next we will go to the physical properties and the chemical properties. Okay, one second. Yes, so physical properties we will discuss, and in chemical reactions what all things we are discussing. Okay, so this is the preparation method. Chemical reactions we will discuss in further. Okay, fine. First coming to physical properties, what all there are there in the physical properties? Boiling point. So they have very higher boiling points than aldehydes, ketones and even alcohols. Okay, because of extensive hydrogen bonding. We have two O groups, right? So in carboxylic acid we have two oxygen groups, right? This can also react, this can also form hydrogen bonding. So due to that, this exists, or this compounds have very high boiling point. The solubility is also high, but solubility will decrease with the increase in the number of atoms. If here more number of atoms will come, then solubility will decrease. Higher carboxylic acids are practically insoluble in water due to the increase in hydrophobic interaction. Okay, so higher if you increase, that is applicable to everyone. Now talking about the chemical reactions, which is very, very important. Yes, now see, as we have seen in the case of alcohols, there was a bond in which OH bond can break, and there was another reaction where CO bond was breaking. The same thing here also is there. First, cleavage of OH bond, in that you have acidic nature and reactions with metals and bases. Okay, that's the first thing. Then when there is cleavage of COH bond, okay, COH bond, you have anhydride formation, esterification. This reaction we already know. Reaction with PCl5, PCl3 and SOCl2, this also we know. Reaction with NH3, this also we know, it will give you amides. Next, reactions involving the COH group. So that is your reduction and decarboxylation. Now reactions involving the hydrocarbon part, you have halogenation and substitution. Okay, so let us have a brief what I am talking about. When the reactions where there is a cleavage of OH bond, there we have two types of reactions with metals and reactions with bases and the acidic nature. The second thing is there what? Reactions involving the cleavage of CO bond. Okay, CO bond, that will break. In that what all things we have? In that we have esterification, anhydride formation, reactions of PCl3, PCl5 and SOCl2. Okay, 3 I told, and then reaction with ammonia. Four type of reactions are there. Next, reaction involving the whole CH-COOH group. In that you have reduction and you have decarboxylation, reduction and decarboxylation. Then reaction involving the alkyl part. Okay, so see, if I draw the structure like this, see, the first category is where this bond is cleaving, okay, or this bond is breaking. You have reactions with metal, reactions with bases and acidic nature. The second one is where this bond is breaking, means this OH will be replaced with something. In that we have anhydride formation, esterification and reaction with PCl3, PCl5, SOCl2 and ammonia. Now next one is where this whole COH group is involved. Okay, there what all reactions we have? Reactions, that is your reduction and decarboxylation. Now the reactions where this R group is involved, this COH remains as it is, but this R group is involved. There you have halogenation and substitution reactions. Okay, clear? Let me just give a diagrammatic view of this one. See, you have this R. Okay, when this bond will break, what all reactions we have? Acidic nature, okay, reactions with metal and reactions with bases. Next, when this bond will break, okay, let me choose a different color. If this bond will break, what all reactions we have? We have reactions, that is esterification, anhydride formation, okay, Then we have reaction with SOCl2, PCl3, PCl5, and then we have one more reaction, that is reaction with ammonia. Okay, now coming to next one. Yes, if you involve this whole COOH group, there what all reactions we have? Here we have one is your reduction, okay, reduction, okay, another one is decarboxylation. Okay, now if I do just involve this R group, okay, this one is not disturbed, only in this R group what reactions I have? One is your substitution reaction, that is HBZ reaction or halogenation reaction, and I have substitution reaction. Okay, so this is how you should remember part by part what all reactions are covered. Okay, next moving forward, we will discuss the first part, that is your cleavage of OH bond. We have here acidic nature reactions and reactions with metals, and yes, so you can see here acidic nature what is there? More acidic than phenols. They are definitely more acidic than phenols. Electron as completely similar to phenols, electron withdrawing group will increase the acidity. And what is the order of electron withdrawing group? CF3 is the most strongest electron withdrawing group, then NO2, then CN, then fluorine, chlorine, bromine, iodine, and phenyl group. Now coming to the reactions with metals and alkalis. So if RCOH is there, if you treat it with Na, so you will get RCOONA plus H2. If you treat it with NaOH, okay, so you will get RCOONA plus this OH and H will give you water. Now you remember phenol does not react with NaHCO3, but carboxylic acids can react because carboxylic acids are more reactive than phenols. So if I just make a order of this one, so first is your RCOOH, okay, then NaHCO3, I am talking about their acidic order, and then you have ROH. Okay, so that is why alcohols cannot react with this one, but yes, this one can react with this one. So here you have a base, you have an acid and you have a bicarbonate, so byproducts will be CO2 plus H2O. Okay, salt plus CO2 plus H2. Now this is the order given, so CF3 is the highest one, then CCl3, then CCl2. From here questions are not asked, but yes, this order you can just guess, just see this order. So that is the first type. Okay, next here where there is cleavage of CO bond, there are four reactions we have discussed: esterification, anhydride formation, PCl3, PCl2, 5 SOCl2, and ammonia. Okay, so first we will see this one. One second. Yes, you can see this first one. What happened? How this OH bond is breaking? That is the thing you should see. Okay. So when there is anhydride formation, what happens? From one of the carboxylic acid, this bond will break. Okay, and this H2O will be removed. From here OH bond is breaking, but from here this bond is breaking, right? So we are talking about those reactions where this bond will break. So water will be removed in presence of what? You can take P2O5, you can heat it, or in place of H plus or means acidic medium and heating it. So here what will happen? You will get one anhydride formation. Okay, first reaction. The second one is your ester formation. So in alcohols this bond will break, but in acid this bond will break, and we will get in acidic medium one esterification. Okay, so this is your first one, that is anhydride formation. This is your second one, that is esterification. Okay, now if you have PCl3, PCl5 and SOCl2, this OH group is replaced with chlorine. So again this bond is breaking, right? OH is replaced with Cl, PCl3 OH is replaced with Cl, SOCl2 OH is replaced with Cl. Okay, so that is here what reaction with SOCl2, PCl3 or PCl5. Next we have reaction with ammonia. Okay, so this is again very interesting one. See, ammonia is a base and this is an acid. So whenever base and acid will react, what will happen? We will get a salt. So first what happens? We get a salt like this, CH3COO minus. Okay, this will donate the H plus because it is an acid. It will accept a H plus. So CH3COO minus NH4 plus. This is the compound formed. Now when you heat it, what will happen? Water will be removed. So you see how the water is removed. See, you have CH3, okay, C double bond O, O, I'll write this NH4 like this, H2 NH2, right? This NH4 I am writing like this. So from here this part will be removed. So you will get an amide in the product. Okay, so that is what is the main product formed here. Okay, now here you can see this is also will, so directly what you have to do, you have to remove this OH group and you have to add NH2 there. So you will get this one. Okay, now here what will happen, see here also first the same thing will happen, you will get NH2 NH2, okay, and here also you will get, okay. Now from here what will happen, NH3 will be removed. Okay, so you will get, see, one N, one 2H and one H will be removed. So you will be left here with NH, NH. Okay, clear? Fine. Now coming to the where the reactions of COH whole group is involved. There we have two types of reaction. One is your decarboxylation reaction, another one is your reduction reaction. So reduction reaction, we know in reduction what will happen. Yes, you can see here. Okay, so in reduction, this is this reduction reaction with lithium aluminium hydride or ether or with B2H6, this group gets converted to acids, right? Acids gets converted to alcohols. Now decarboxylation reaction, what happens? This CO2 group will be removed, right? That COO part is involved or not. So that comes under this category. With NaOH and CaO, that is soda lime, this is called as soda lime. Okay, so with soda lime what will happen? This group will be removed and you will get RH. Okay, so directly RH and Na2CO3 is formed. So product you should remember RH forms. Next is what? We have reactions involving the hydrocarbon part. So that is halogenation and substitution. So in halogenation, this is called as your very important one, HVZ reaction. So HVZ reaction, we need alpha hydrogen. Okay, so this is the carbon, alpha carbon. So alpha carbon should have one alpha hydrogen. Okay, now when you treat it with X2 and red phosphorus, X can be chlorine or bromine, one of the hydrogen is replaced with X. Okay, so that is your HVZ reaction or Hell-Wohler-Zielinski reaction. Now coming to this one, that is your substitution reaction. COH group is an electron withdrawing group. Okay, so electron withdrawing group means it will be meta directing in nature, right? So if it is meta directing, nitro group will come at the meta position and here bromine will also come in the meta position. Clear? So that is your substitution reaction. Okay, now let's do some question. Which of the following will undergo HVZ reaction? So what is the condition for HVZ reaction? We need to have alpha hydrogen. Okay, so you see here there is alpha hydrogen, so it will undergo. Here you can see this is alpha carbon, alpha hydrogen is there. 2,2-dimethyl propionic acid. I think this one will not have. I have propionic acid and I have 2,2-dimethyl propionic acid. Yes, this carbon is not having any hydrogen, so this can be the answer. Next, 2-methyl propionic acid. So if I draw 2-methyl propionic acid, okay, so this also has an alpha hydrogen, so this will not, option number C is the correct answer here. Okay, next, which reagent would bring about this transformation? RCOH to RCH2OH, lithium aluminium hydride in ether, right? Option number D. Next, which of the following will not undergo HVZ reaction? Simple question again. Formic acid, if you see, you have H, C double bond O, OH. There is no alpha carbon, no alpha hydrogen, so that is why this has to be the answer. Okay, next. Okay, we'll see this question. CH3 is used with Br2 and phosphorus. So that means HVZ reaction, here there will be Cl group, right? So you will get CH2Cl, COOH. After that, this is your Y. Next, what you are doing? KCN and H3O plus. So KCN will convert Cl to Cn, right? And after this Cn is formed, if you do hydrolysis, you will get COOH here, right? So what I will get? CH2 COOH and COOH. So this is which compound? You remember OMSGA. So if there is one group only, so it is malonic acid. That is option number D. So if you know, you might do the product, but if you do not know this one, you will not be able to answer. So that is why I told you that OMSGA is very, very important. Okay. Next, yes, so we have, that's all. So students, I hope that this video will be helpful. This is one entire package. You will be learning everything whatever is required, and you should be following our Brahmastra series, our Decode NCERT. Every series is designed to help you to get full marks in KCET as well as in your PU exams. So please share it with your friends, share, subscribe the channel so that you don't miss out on any important things. Okay, that's all students, and I hope your preparation is going very well. Any help you need, please do comment down. We will definitely address to it. Okay, thank you and see you soon in the next class.